All right, what's up, guys? Welcome back to another episode of Narnia. We'll keep working through this over-the-wire Narnia box, doing the exploitation. Now we're on level 1 at this point. We just did level 0 last week. So yeah, let's just get right into it. We are SSH'd into the box. So first thing we're going to do is go into the Narnia directory, and we'll see all the different files here. We are currently the Narnia 1 user, so what we're going to do, if we take a look at the permissions of these files here, we'll see that this we have permission via the group permission to execute this Narnia 1 executable here, which is based off of a C program. It is a C program, but that is owned by Narnia 2. So if we can spawn a shell by exploiting this binary here, then that shell will be spawned as Narnia 2. So thus we will elevate our privileges to Narnia 2, which that is the whole goal of what we're trying to achieve here. So let's just take a look at this Narnia1.c file and see basically what it has going on. All right, so pretty simple looking program just right off the bat here. So don't have to worry about the comment up here. Basically, standard import here, just the standard IO header file. And then as we look into the main function, not too much is going on really. We are basically grabbing the this pointer here, this return pointer value. And we're checking for our environment variable, the egg environment variable. And if it has not been set, meaning it is null, then it's going to print this message, give me something to execute at the environment variable egg. And if there is some kind of data assigned to that variable, then it's going to try to execute. Now, we're not exactly sure what that entails, like what kind of execution is being done. But let's just start by just running this file to kind of test out what appears to be happening so we can confirm. If we just go ahead and run this, we see that it does print off, give me something to execute because we didn't set our egg environment variable. So if we go ahead and do that, we'll do that by exporting this environment variable egg as whatever. Let's do pwd for print working directory. All right. So now we should be able to echo that just to confirm and see pwd there. Yep. And so now if we go back and run Narnia 1, we get a segmentation fault. So because there was data in this egg environment variable, this if condition was not triggered. Instead, it skipped over that to this. And actually tried to execute. See, it printed this message saying try to execute it. But then when it tried to actually assign value to this return variable here and return it, looks like there was some kind of unexpected error. So we're going to need to get a little bit more information on what it was trying to do and what happened. So basically, in order to do that, what we're going to want to do is we're going to want to use a debugger to get this information. Now, fortunately for us, on pretty much all Linux systems, it has a debugger called GDB. This one happens to have that. Almost every Linux system you encounter will have this. Not 100% of the time, but there's a lot of other Linux debuggers you could use as well. But this one seems to be the one that is most consistent across Linux systems. And just for example's sake, we're going to use this particular debugger in this example. So if we say GDB and then execute it, we can see we jumped into the debugger here. It's a command line based debugger. So it might be nicer to have a GUI one, but a lot of times as an attacker, you're not going to have access to a GUI environment on the system once you've already exploited it. Now, you can create your own. You could stand up this particular software. If it's like a third-party software, you can download it on your own test machine and then have your own tools and get it working first and then port it over. But obviously, in the context of this CTF, we're fine just to do it on the system here. So we are in GDB here. It's a command line based debugger. So what we're going to want to do is we're going to disassemble the main function, because that is pretty much where all of the interesting stuff seem to be happening. And particularly when we actually make the call to the EAX register, that's what we want to pay attention to, because that corresponds to where we actually try to return it. So we want to set a breakpoint there so we can see what's happening in the register there. So the way we can do this in GDB is type break and give it the asterisk here, and then give it that memory address. Another thing to note is, where is it? Right here. This is where it's writing to the console. If you were curious, that's where it's saying trying to execute egg. That'd be at this register right here. This call. So let's just go ahead now and I did not copy that properly. Let's go ahead and copy this register here, paste it in, set this breakpoint. Now that our breakpoint's sent, if we type run, it will go ahead and run it all the way up until this point. So now we can observe the registers. So the way we want to do that is we want to look at it in hexadecimal. So that's why we have x/. This is how you do it on the GDB command line. And we're interested in like about 25 length. So we do 25x here. And now that'll give us 25 hexadecimal characters. So once we do that, we want to tell it what register. So we do $sign to denote a register, and then we type EAX. So that's a register that we want to look at, obviously. So upon doing that, we see here a number of addresses that come up. If we look at this first one, right? Let's just go on the internet. Let's make this a little easier. We're gonna search hex to ASCII and find a converter. Let's check this one here. So we put in this. Might need to, okay, that doesn't look right. Let's remove this little prefix here. Where was it? There we go. If you remove the hexadecimal kind of prefix data, what we see is this will translate into DWP. Now, this might not look like much, but if you consider that it's using little endian format, that means things are reversed. If we reverse this, it's PWD. Now, what was that? That was the data that we assigned to the egg environment variable. So we see that there. So if we can control that, then we can likely spawn a shell, right? So what we can do is we can go to a site that I like to use for getting shell code for different operating systems to actually spawn shells, like for really good type of stuff for exploiting, doing local exploits, basically. There's a site called shellstorm.org. You go here. Let's see here. Having some issues here. I know I had pulled this up. Let's see, not secure. If I can go there. Anyways, worst case, we can do that on a new window here, right? So let's do shellstorm.org. And yeah, not sure why I wasn't able to pull that up on the VM, but here we go. There's a number of shells here, and honestly, it took me quite a while to figure out which specific shell that I needed for this situation. But eventually, through a little bit of trial and error, what I found was this particular one right here. The shellcode 607.php. So particularly what we are interested here in is this shellcode. So if I copy this, okay, what I can do then is we can create a file out of this, right? So let's say we create a file, call it shellcode. I'm going to need to massage this data a bit. All right. Let me show you some Linux stuff here that can help you when you're in this situation, right? So you get the shellcode like this. The issue is we need to remove the single quotes and we need to remove all this white space here. We don't need it. So in this type of situation, what we can do is we can use TR to remove this white space, which I think it stands for translate. What is it? Yeah, translate or delete characters. So TR for translate. It's a command line utility. I haven't really covered it on this channel yet. Perhaps I'll do that in the near future. But for now, I want to do -D for delete. And then you give it this sort of keyword here, blank. And that's just a little indicator for it to know that you want to, remove these blank lines, delete the blank lines. So then you give it the redirector in to tell it what to take input from. In this case, we want it to take in shellcode. And then what we want it to save the file as, we'll just do SC for shellcode. So if we run that, if we look at that file now, we see that it removed the white spaces. Now, the next thing we want to do is we want to remove these quotation marks. So we can use sed for that. So S for find and replace, we're going to look at, and if you're not familiar with how to use sed, definitely check out some of my other videos on sed. I've covered how to do a find and replace here. But basically, we're going to look for quotation marks, replace with nothing globally on this file. And that will give us that. And we can go ahead and save this as shellcode. So now when we cat shellcode, we'll see that it's here. It's pretty nice. And so the next thing that we're going to want to do is get this all on one line. That way we can just copy paste it over. So once again, we can use TR to do this. Now, as always with Linux, there's multiple ways of doing the same thing. This is just how I'm electing to do it. Feel free to do it however you so choose. So if we want to use TR for this, what we can do is we can cat this shellcode, pipe it into TR, and say -D for delete, and we'll put the new line character here. We want to delete the new lines essentially, right? And so we can just pipe that out to SC. And so if we cat SC, there we go. So we didn't really need to pipe that out. We could have just ran it like this without piping it out or redirecting it out. Have it like this. Because basically all we need to do from here, we have it all on one line without quotation marks or anything. So we can just copy it in one fell swoop like that. So now that we have that, we can go back to the SSH session here that we have. And that's pretty much all the info we need from here. We can quit out of GDB. What we're going to want to do is go back to this export command on the egg environment variable. And we can actually use Python to generate our hexadecimal payload, all right, our hex code payload. So if we want to do this in Python, from the command line as like a one-liner, the way we can do this, and this is something you just kind of memorize. You'll be doing it a lot with exploitation and buffer overflows and stuff like that when you want to use Python to actually inject inline payloads. What you would do is you do this $sign here and then quotes and then Python and then -C and then a single quote, tell it to print. And then within double quotes is where we put our hex code. So I paste that in there. I close out the double quotes, close out the single quotes, and close the parentheses. All right. I hit enter there. And now in our egg environment variable is actually our payload. So remember, it is actually executing what's inside this egg environment variable. Go back to here, this EAX register, right? So when we run it this time, what should happen is it should actually trigger this payload to spawn a shell. And of course, it is running as Narnia 2, so that shell should be a Narnia 2 shell. So clear off the screen. Let's go ahead and try that now that we have that set. And we notice we have a new shell. Let's see, who am I? Narnia 2. So just like that, we were able to elevate our privileges to Narnia 2. And from here, I can get the password for that and then SSH into that box and do the next one. So yeah, I hope this video was of help walking you through Narnia level 1. And yeah, if you've been enjoying the content so far, be sure to subscribe and hit the like button as well. Leave any comments down in the section below as well. And I will see you guys in the next video.